Hello, welcome to Selective Prep for Power Math Reasoning Test 21. Okay, question 1 says to make a packet of mixed nuts and mixes together four bags of peanuts with one bag containing 30% almond and 70% pistachio. So all the bags have the same volume. What percentage of the volume of the packet is almond? So we have 4 bags. These are all peanut ones. And then the last bag is 30% almond and the other half, or other 70% pistachio. And it's basically trying to ask how much of the almonds, or what percentage of the entire set of bags is it almond. So we know that this part is 30%. So what we can do is 30% all over the 5 bags. So this means that 30%, this means 30% divided by 5, which is just 6%. So we get answer B. Question 2 says an equilateral triangle ABC is fixed in its position. 2 of the 4 small triangles are to be painted red and the other 2 are to be painted blue. So how many different ways can this be done? We can try and list out how many ways we can do it. If I say this first one is red, then I have one option here, or I can do it here, or do it here. So far I've got 3 options. And then I can also color perhaps this triangle red, and then again I have not 3 options but 2 options, because this one we've already counted in the first cycle, so we can do it. We won't have to count that one again. We can count this one and this one, which are both now new combinations. And lastly, I can also have, if the middle one is red, then the only other combination I haven't done is this bottom right one. So one more combination. And if we add this together, this would be 6. So the answer should be D. On an average day, Australians spend $78,000 buying video games. Of this total, $55,000 is spent on PlayStation games. So how much do they spend on other video games in a week? So in one day, they will spend 78,245 minus 55124 on other games. And then this number, we can now times this by 7 to get the final answer. So that would be answer D, about 161,000. Right, question 4 says the average of 4 different real numbers is 6. So which of the following statements must be true? So 1, 2, 3, 4. And we know the average is roughly 6, or the average is 6. So the total must be 4 times 6, which is 24. So the first statement says 2 of these numbers are less than 6 and 2 are greater than 6. That doesn't necessarily have to be true. One of the numbers could just be 6 as well. 2, if the smallest number is 0, then none of the numbers is greater than 12. If the smallest one is 0, but then we can also have the second one be 1 and 2. Second and third can be 1 and 2. Then this has to be, if we do 24 minus 0 minus 1 minus 2, that's minus 3. So this could be 21. So 2 isn't correct. And we can check number 3. At least one of the numbers is less than 6. Yes, that's true because it's the average. So perhaps one of the numbers is 6, then one of the numbers also has to be something less than 6 as well, and something greater than 6. So for example, if 6 is here, then that wouldn't work out because the smallest we could have is 7, 8, and 9. If we take the average of these numbers, it should be 7.5. So that means that if we want the average to be exactly 6, then some of them have to be smaller than 6 as well. So if we only want the third statement, then that would be D. Okay, question 5. Two cars are traveling towards each other on the same road, and one of them is traveling at a speed of 55 kilometers per hour. The other one's traveling 45, and they're currently 2,500 meters apart. So how far apart will the cars be 1 hour before they meet? So this strip of road is 2,500 kilometers. One is coming at 55, and the other one is coming at 45. So the time it takes for them to meet will be when 55 times by that time, I'm going to say it's t, is also equal to, or plus that time, plus 45t will have to equal to 2,500. And the reason for that is, if you think about it, when they meet, it will probably look something like this. And this distance has to add up to 2,500. And we know that they have to have the same amount of time as well because they start at the same time. So we can write this expression here. That means that if we simplify this a little bit, this will be trying to say like, it's like the same as saying going all this way in just 90 kilometers per hour. 100 kilometers per hour. So I can also just say this is 100 kilometers per hour times by that time will equal to 2,500. And we know from distance, speed, and time that time will be that distance divided by that speed. So if we cross out the zeros, this will be 25 hours. So if we want 1 hour before they meet, then that means it's 24 hours. So we can find 45 times 24 and also 55 times 24 to see where they are. This is 1320 and this is 1080. So it'll probably look something like this: 1080 kilometers and 1320 kilometers, and we're trying to find this distance here. So to find this distance, we want to do this whole thing, which is 2,500 kilometers minus these two distances. So that would be 100 kilometers on the dot. Another way to do it would just be that this 100 kilometers per hour, if we use this instead, the bottom one. If we use this instead, then all we have to do is how far it goes in 1 hour, and obviously that would just be 100 kilometers. So it will be answer D. Okay. Question 6 says to find a rule for toothpick sequence. So in the first one, we seem to have 6. And in the second one, we have 2 more. So 8. And then the next one, we add 2 more again. So it seems like the number of toothpicks will be, we can check each of the answers. For A, it says 2 times the sequence number. That's not true. B, 2 times the sequence number plus 4. So that one works for 1. That'll work for 2. 2 times 2 plus 4. So that works. And then for 3, 2 times 3 is 6 plus 4. That also works. So we can just double check through other answers. So obviously this one will also be wrong. Sequence number plus 2, that would be wrong. Sequence number plus 4, and that doesn't work either. So the answer must be B. Question 7. Blackburn's taxi service charges $3.50 for the first kilometer and $2.80 for each additional kilometer. So if the cab fare was $81.90, how far did the taxi go? So we know that the first kilometer is just $3.50. So in other words, if we go 1 kilometer, this will just be $3.50. And then anything after that, so I'll say D kilometers, this will be 280 times that d, or how much distance we've gone. So if the cab fare was 81.90, then 81.90 was to be in this whole thing. Or in other words, we know that 350 would have been charged here. Then we want to find how much was charged here, which will be 81.90 minus 350, and that will be 7840. So that means that we can now divide this by $2.80 to see how much that distance is. And that would be 28 kilometers. You can double check 28 times $2.80 should give you that 7840 back. So the answer would have been B. Oh, oops. I did make a mistake. I forgot that just this strip is 28. So this strip is 28, and we also have to add in that additional 1 kilometer from the start. So that means that the final answer should have been 29 kilometers. So 28 plus that additional first kilometer we traveled. Right, question 8. A department store parking lot has space for 1,000 cars. 2/5 of the spaces are for small cars. On Saturday, there were 200 small cars and some big size cars in the parking lot. The parking lot was 3/4 full. So, how many big size cars were in the parking lot? So first of all, there is 1,000 spaces for the cars, and we know that the small ones are allocated 2/5. That means the big ones will be given 3/5 of the parking lot. So 1,000 or 2/5 of 1,000 will be 400. 400 spaces for the small ones. That means big ones get 600 spaces. And on Saturday, we know there was 200 small ones, and we don't know how many big ones, but we know that this was 3/4 full. So 3/4 full actually just means 750 cars. So that means that for the big size cars, there would have been 750 minus 200, which is 550. So that means the answer would have been D. Okay, question 9. Suzanne passed around a basket of cherries to the girls at a party. Before the party, she ate 5 cherries and gave a friend 3. And then 8 girls arrived at the party. The first took 1, the second one took 3, the third one took 5, and so on. We have Suzanne, and then we also have a friend, and then we also have the 8 other girls. So Suzanne first took 5, her friend gave 3, and the first girl had 1, the second has 3, 5, 7, 9, 11, 13, and 15. So if we add all of this up, we should get the answer. Since the last girl, once she took her cherries, the basket was empty, and we're just trying to find how many cherries were there. So if we add it up, we get 8 plus 4 plus 5 plus 7 plus 9, 11, 13, and 55, or 15. That should have been 72, which is answer B. Okay, question 10. Tiling is on sale, and Mrs. Martha is looking for some tiles for her bathroom. Her bathroom is 3 meters by 5 meters. So, how much would it cost her to do it at this sale price? Her bathroom is 3 by 5, so this is 15 meters squared. And we know that it is 20% off, so we can find how much that would be. So in other words, if it's 20% off, that means it is 80% of the original price. So I can just do the original price times what is 80% of it. So 0.8 will give us the new sale price. That should be $5.24 per square meter. So if we just do 15 times 524, we should get the answer. That will be 78.60. And that's it. Okay, just some key points for this unit. For the number of ways questions, it's better to try and find a pattern, or maybe try to list out all the possible ways. Kind of depends on the question. For this case, it was easier to find all the possible ways rather than to try to find a pattern. You can always use multiple choice answers to guess and check, or go back and look at a question to see if it works. For example, like that, what was it, like the sticks question? Yeah, that one would be good to use the multiple choice answers, or even a cherries one would have been okay to use as well. Draw a diagram or a table to try and simplify any information that's given in a question. I think this helps a lot, especially when it's hard to picture it all in one go. So I think a table definitely helps as well. Okay, that's all. Thank you.